Chief guest of today's function, Dr. Kamachi Mudali, Vice Chancellor, Homi Bhabha National Institute, Mumbai. Guest of honor, Dr. Ramji Singh, Member, Dam Safety Review Panel, Govt of Gujarat. Dr. Raja Shankar, Dr. Parivallal, Dr. Prabhakar, Chief Scientist, Sri Loknath Patnaik, Administrative Officer, Sri Anish Pasha, Finance and Accounts Officer, Sri Mahesh Kumar, Controller of Stores and Purchase, Professor Santosh Kapuria, former Director, CSIR-SERC, Dr. N. Gopalakrishnan, former Director, CSIR-CBRA, Dr. Sakaria George, Dr. Gomati Lakshmanan, Srimati Shrita Nakesh, our beloved seniors who have laid the foundation of this institution and blessing us today, friends who support us from neighboring institutes. I could see Dr. Ravindra Gettu and Professor Shekhar over here. And invitees, my dear brothers and sisters of this campus, representatives from media and press, ladies and gentlemen, Vanakkam and Namaskar. It is with its immense pleasure and gratitude that I stand before you today to welcome each one of you to the Diamond Jubilee celebration of this great institute, CSIR Structural Engineering Research Center. This is not just an event, it is a moment of reflection, of renewed purpose, and of rededication. We are here to celebrate a remarkable journey from humble beginnings in Roorkee to leader in structural engineering from our campus in Chennai. Civil engineering is a way of life, grounded in planning, teamwork, experience, and readiness for the unexpected. Structural engineering in particular applies scientific knowledge to build the very backbone of civilization, buildings, bridges, dams, railways, and infrastructure that support daily life and national development. The safety, sustainability, and economy of these structures depend heavily on the vision and innovation of structural engineers. Most of us who are currently serving this organization not even born when this great institution was founded. Yet today we are proud torchbearers of legacy of excellence. Building an institution is not just bringing people together, it is bringing the spirit of working together for the benefit of the nation and mankind. That is what CSIR-SERC, with one spirit for 60 years, we have served the nation. As in many sound structure, our institution stands on strong foundation of values, vision, and collective resilience. Thiruvalluvar says, "Ulluvadellam uyarvullal, mattrathu thallinum thallame neerthu." Let our aspirations always be noble and high. Persistent efforts will never go in vain. So our journey began with the visionary Professor Dr. G.S. Ramaswamy, who laid the conceptual and the structural foundation of this institute. On June 10, 1965, following a decision of the Board of Scientific and Industrial Research, SERC was born in Roorkee. It was not just a dream, it was a mission turned into reality through relentless dedication. The institute moved to Chennai, establishing a regional center in 1966, and by 1969 it became full-fledged laboratory. The early infrastructures, a structural testing laboratory now known as SMSL, Special and Multifunctional Structures Laboratory, concrete testing laboratory, and iconic shell structures embody in-house techniques reflecting our core philosophy, research that serves real-world needs. Each building on this campus has a technical story behind it. The funicular shell roof of the concrete testing laboratory, the brick shell roof of heavy testing laboratory, grip bars, George Ramaswamy improved performance, embedded in heavy-duty floors, gifted generously by TISCO. And one of the founder, George Zakaria, is here. Thank you, sir, for being here and blessing us. The hemispherical braced dome, patented by CSIR-SERC and used in Bach's Central Auditorium. So our institute contributions goes this way: cold deform bars, and India's first fly ash buildings in 1970s, prefabricated construction techniques in early 1970s, pre-stressed hyperboloid, cyclone shelters, 23 number, protecting nearly thousands of lives every cyclone, and structural solutions for turbo generator foundations, fatigue studies and pipeline design, structural health monitoring of bridges and dams, durability studies and reinforced concrete, societal contribution and strategic sector, the ultra-high performance concrete and real-time hybrid simulation, and many more. So we organize ourselves in 6 thrust areas: structural health monitoring and life extension, disaster mitigation, advanced materials for sustainable structures, special and multifunctional structures, energy infrastructure, and offshore structural engineering. Morning we had the developments that is happening in these 6 thrust areas and a panel discussion, and the grand challenges were identified. And we have 10 different laboratories, and some of the key facilities. The latest name is shown over here. Initially, fatigue testing laboratory turned into fatigue and fracture laboratory, tower testing research station, stress analysis lab, later foundation for the today's SHM lab, advanced mechanics and protection structures laboratory, advanced materials laboratory, steel structures laboratory, and advanced concrete testing and research laboratory, wind engineering laboratory. And have all been milestones in our journey. And a video will be played after this speech, highlighting the key contributions of CSIR-SERC. And happy to share with you, this year we have crossed 25 crores of ECF, and I thank each one of my scientists and the technical staff and the supporting staff, administration, purchase, and finance and accounts, for this greatest achievement which we have made this year. As disaster takes shape, awareness of structural resilience, our focus extended to structural dynamics, the mother of A-Star Lab, computational structural mechanics group, and shock and vibration lab, wind engineering lab, all contributing to safer structures. Let us remember the pillars of our leadership. So these are some of the activities which our institute has been doing. NDT for safer structure, the map shows at various locations, and our contributions to BIS codes. So the pillars of our leadership, Tirukural goes, Anjamai Ihai Arivu Ukam Innangum Enjamai Vendarki Yelbu, which means that courage, generosity, wisdom, and tireless energy are the everlasting virtues of leadership. And the leadership throughout the decades have been visionary with all the wisdom and energy to venture into new areas of research. Professor GSR, synonymous with shell structures and grip bars. Dr. Sakaria George, a cornerstone in revenue generating technologies. Dr. Ramaya, who developed this campus and tower testing research station. Sri Raman, the visionary, software visionary. Dr. TVSR Apparao, pioneer of computational dynamics and architect of this particular auditorium, Vigyan Auditorium. And Dr. Lakshmanan, the architect of A-Star and wind engineering research. Professor Nagesha Raiyer, who transformed our campus with new look, and NAFAMS is the facility created by him. And Professor Santosh Kapuria, who brought in high-performance computing and mission mode programs. And today we have the Professor GSR internship students joining. Today 10 of them are joining. And Dr. TVSR Apparao internship, 65 students are disruptive game-changing technology. Let us not settle for being national leaders. We must try to become a global benchmark. My sincere thanks to every past and present staff members. Each of you is a vital part of this journey. It is equally important the family members of the staff who have been moral support for the contributions made by the individuals. I thank my team. They are like Panchaputas, who embrace silence and give space like sky, nurture like earth, flow and adapt like water, act swiftly like air, and transform like fire. Today, as we celebrate our 60 years of excellence, let us rise to even greater heights. My dear sisters and brothers, it is also our collective responsibility to continue excelling and hand over the torch to the next generation with pride. I express my heartfelt gratitude to our chief guests and guest of honor for gracing this occasion with their presence despite their busy schedule. Thank you, sirs, for being here and gracing the occasion. I once again welcome you all for this Diamond Jubilee celebration, let me close with a Tirukural. En பொருளவாக செலச் சொல்லி தான் பிறர் வாய் நுண் பொருளா காண்பது அறிவு. True wisdom lies in expressing complex ideas in a simple manner and understanding the subtle thoughts of others. So that is what we try to do in research. Our solution should be simple and effective, while complex underlying science should be understood with clarity. Thank you all.
Thank you so much, ma'am, for your inspiring words and for being a torchbearer of CSIR-SERC's legacy and future. You have set the right tone for our celebration. And now let us take a moment to revisit the remarkable journey of CSIR-SERC, presenting a special video that captures our milestones, memories, and moments of pride.
Vision. There stands a name that has not only upheld India's infrastructure but elevated it. For 60 years, CSIR Structural Engineering Research Center has turned
Share this moment of pride with you as we celebrate 60 glory years of CSIR Structural Engineering Research Center. Over the decades, CSIR Structural Engineering Research Center has stood as a beacon of scientific excellence. Our journey has been marked by significant contributions to infrastructure safety, disaster resilience, defense applications, and capacity building. Beyond this, we have built trust with society, with industry, with every young mind that cross our doors. As we commemorate this milestone, we look ahead with renewed energy and commitment to sustainable solutions, digital transformations, and inspiring the next generation of engineers. I would like to quote a Tirukural, பொருள் கருவி காலன் வினை இடனோடு ஐந்தும் இருள் தீர எண்ணிச் செயல், which means do an act after due consideration of the five: money, means, time, execution, and place. That is what every engineer should do and will do. Thank you for being part of this celebration.
from early forms to engineering function, India's needs began to grow, and SCRC stepped up to build the nation's load-bearing legacy. From railways to coastal bridges, the nation's lifelines demanded innovation. CSIR-SERC's pre-stressed concrete sleepers redefined railway durability. For the Pamban Bridge, the gateway between land and sea, it was our research that re-engineered it. The ingenuity didn't stop there. Space grid roof structures, composite girders, and anchoring systems like HEAD-T accelerated construction across India. As India accelerated, so did its risks. The call wasn't just to build, but to protect. In times of disaster, defense, and danger, our work became a shield. From blast-proof shelters using LSCC panels to bulletproof booths for border security, every structure was designed with safety in mind. Nature inspired our innovations like biomimetic FGCC panels for impact protection. We engineered floating platforms for offshore renewable energy, SFCC for thermal shielding. But even the safest structures need ears. Monitoring became the silent guardian. Acoustic emissions, fiber optic sensing, drone-based inspections. CSIR-SERC made structures talk. From railway bridges to defense equipment, our SHM systems access, diagnose, and predict failures. CIMES brought real-time data. To build smarter, we need smarter materials and smarter minds. We pioneered a renaissance in concrete, from Sifcone and LRC to concrete cocoon crafted by 3D printing. We introduced India's first fly ash building, polymer impregnated mortar and geopolymer concrete for eco-friendly mass construction. The journey includes lightweight EPS panels, textile reinforced concrete, and sensor embedded materials. And in defense of sustainability, we offered carbon capturing materials and fly ash aggregates. Innovation wasn't confined to labs, it extended to people. When cyclones struck, we built resilient shelters. When pandemics hit, we delivered makeshift hospitals overnight. Polytal M shelters brought foldable innovation to disaster zones. Through Jigyasa and Atal Tinkering Labs, we inspired young minds, and through national standards, we raised the bar for all. Our science touched cities and skies and even the poles of the planet. Our structures adapt across environments, from seismic zones to Antarctic stations. We helped to create hardened hangars for aircraft, upgraded heritage temples, and studied fuel tank slush in LCH and Tejas aircraft. And when the future flew towards air taxis, SERC tested them in the wind tunnel. All these advances were not mere applications. They were born from knowledge. For decades, the Journal of Structural Engineering chronicled research trends. With over 2,000 papers, landmark handbooks, and patents, our contributions resonate beyond borders. Through ACSIR, we nurtured scholars who now lead innovations worldwide. But 60 years behind us, we now ask, what lies ahead? The road to Viksit Bharat 2047 and beyond is intelligent, resilient, and inclusive. We are advancing digital twins for SHM, nature-inspired materials, climate-resilient retrofits, and indigenous floating RE systems. We are designing for space and inclusive cities across AI-powered diagnostics, engineered composites, and human-centric innovation. Whether it's high-speed railways, CSIR, one spirit. We are designing for space and inclusive cities across AI-powered diagnostics, engineered composites, and human-centric innovation. Whether it's high-speed railways, CSIR-SERC stands ready for the future. 6 decades, countless breakthroughs, one spirit. From domes to digital twins, from the heart of Chennai to the edges of Earth, CSIR-SERC's journey is a testament to India's structural ingenuity. 60 years of service, science, and spirit have laid a strong foundation. Yet, the next chapter is only just beginning.
Thank you very much. As we look back on the many milestones of our journey, it is only fitting to showcase the spectrum of activities that have lit up this Jubilee year, from outreach to innovation, from insight to impact. I now invite Dr. J. Prabhakar to present a glimpse of the Diamond Jubilee activities to the august audience.
Respected Chief Guest, Dr. Kamachi Mudali, Vice Chancellor, Homi Bhabha Atomic and National Institute, and guest of honor, Dr. Ramji, member Dam Safety Review Panel, and our director, Dr. Anandavalli, and dignitaries on the dais and off the dais, and former directors, and professors from Anna University and IITs and other engineering colleges, and students from engineering colleges, and today is in the morning people have attended from industries, entrepreneurs, and my dear retirees, retired staff members, and my dear colleagues. I am happy to see you all. Now the hall is completely filled. So I have been given responsibility to be a organizing committee chairman for the year-long to conduct various activities, and at the beginning to have a remarkable things, we requested our staff members, including the project students and the staff members, to come out with the logo design, which can be always rememberable. It should reflect the 60 years of journey. So that way we have invited the staff members to participate, and we have received number of logo, and finally we have chosen the logo which you are seeing here, and that was designed by one of our project assistant, and he was awarded with a cash prize with a certificate. That was the first activities we have made towards the celebration of our Diamond Jubilee. Next, this one, okay. So the second activities, we have planned to organize different lecture series, and we thought of inviting eminence from different field of expertise. We want to hear their experience and knowledge sharing, and that way we have can you go back? Yeah. So it is going back, sorry. Yeah. The first lecture was delivered by our own colleague. Actually, he was in SERC, and later he moved to National Institute of Wind Energy, Chennai, as a Director General. And he has delivered a lecture on the topic on emerging trends in energy engineering structures. He has covered wide, the things which are the places the wind or more of we can get the more power, and also what is the maximum length of the fan can be designed, and what is its kind of advantage and disadvantage. All those things he was discussing, and what is the kind of power we are generating through wind. So that was spoken by him. And second lectures we have heard from Dr. Mr. U.K. Bhattacharya. He is current our chairman of Research Council, and he is a former director projects retired from NTPC Limited. And he talked about the energy infrastructures with regard to the plants, and he also covered widely on what is the power generation through hydro and thermal, and also through now, because NTPC nowadays they are concentrating on the solar also. So he has touched a wide range of things, how we can tap the power. So that kind of information he has given. The third lecture was given by our Dr. Ravindra Gittu from IIT Madras. He has covered the technology implementation as the key impact of research. So he has particularly focused on the importance of technology which can be useful for the country. And the fourth lectures was delivered by Mr. Mogan Ramanathan, and he was given complete overview of the helical screw files, because nowadays we can drive the file without excavation through rotation mode. So, which are the kind of soils where it can be useful, and which are the places where you can address this kind of screw type, helical screw type of files that he has covered in general. And sixth one is delivered by the Deep Ocean Mission and Blue Economy of Sustainable Development. That is from Dr. M.E. Ramana Murthy, Director, National Center for Coastal Research. He has talked about the deep ocean, how these different minerals can be extracted, and what are the other kind of oil, and how the structures are being erected, and what is its the problem which they are facing, and how SARC can contribute to overcome that issue, and all the things he was covered. And Mr. P.V. Manjure is our research council member, and he was discussing about the how we can rehabilitation of bridges and other structures. So yes, particularly their pre-stressed bridges and all, he was discussing on that. Sorry. And recently we had a person from Mr. A.R. Santakumar, is a Director DGM, IOCL, R&D Center, Faridabad. He discussed about the integrity management of pipeline corrosion. He started with the design as well as material choosing, and also if anything, how to monitor, and if something goes wrong, then how we can address. So all this aspect he has covered. And Dr. G. Raghava is our own colleague of CRC. He is retired, and he has been to Antarctica, and he had gone through some of the activities he has done there. So he has shared complete his experience, and what is that thing SCRC can contribute in future, particularly with regard to some kind of structures. So all these structures was very informative and very knowledge kind of things. So really we have all benefited for this lecture series. Sorry. So the third activities, we also invited different engineering colleges in Tamil Nadu, and we want to make them to to have another scientific temper, so that in future they can choose our civil engineering field. Morning there was some discussion with regard to the people are hesitation to join in the civil engineering field. So already we are also doing a lot of Jigyasa program, where we are people are going and making them to understand. And we have called some engineering students from 19 engineering colleges, and we have contested some quiz program, and there were 3 engineering colleges were chosen, and first, second, third place we are chosen the colleges, and today we are going to honor them with the prize. And we also organized IMAP, that is monitoring, assessment and predictive maintenance of critical infrastructure, as a part of Diamond Jubilee celebration. And the chief guest was Sri Ravindra Kumar Goyal, and the guest of honor was Sri Achyutanand, Director, Chennai Metro Rail. And this was, there were 6 eminent personality they delivered as a keynote address. And this was participated by a number of, almost 200 people are participated, including industries, academia, and students, and etc. And we are also had on the day exhibitions, and about 70 technical papers were presented. And one video is there, just 2 minutes it will be playing. there is further we also conducted the games amongst the staff members, and there was five type of games were conducted. That is treasure hunt, Pictionary, telephone game, tug of war, and poster competition. These games were amongst our staff members it was conducted, and some of the photos you can see, that is a treasure hunt, and it was a quite interesting game. Actually, including our director participated in this game, and really actually they gives kind of we have to choose one kind of paper. There it will be written something. So we have to go and identify that particular object, and once you identify, there is another clue is given in that particular place. So you have to carry that one. So like that, 5 places it will be there. Ultimately, you have to reach the final point. Whoever is coming first, so they will be given first prize. So really, everybody was on that day. They were running like anything. Then people are not knowing, they were they were thinking that something has happened, they are rushing like that. So it was quite interesting. This is a Pictionary and telephone games. So I think people might be knowing, so I don't want to explain in detail. And tug of war, both men and women's were also organized. And poster competition also we organized. And this was the poster competition got first prize. That was by Dr. Bharati Priya and M. Kirtana and Mohit Varma. And second prize was Dr. Prabha and Dr. Lakshmi Purna. Actually, the theme is how in 2040 SERC what kind of status is going to be. So which area it is going to be focused, and that kind of theme we are given. And third prize is won by Dr. K. Senthil Kumar and Dr. P. Ambali. So these are some of the things done by other colleague with the same theme. Okay, but what of time? I'm not playing the. This is today. We have morning. We had Industry Connect as a part of the Diamond Jubilee. These things. I think morning we had a chief guest, Dr. Govindraj, and we also inaugurated our this exhibition, and we had 5 interesting presentation, because we have a major 6 thrust area in our institute. So each thrust area, so we have given presentation what SERC is doing and what done, what are the earlier things are done that has been presented to the industries so that it can be taken into the field. And these are the organizing committees. Really, because of that only the things are very successfully so far. It went well so far, and once organizing year-long activities, it's required a lot of manpower and responsibility from various peoples, and they all supported very well. And really, I thank each and every one of them, and each and every one of the committee chairman also for tirelessly doing their work. And I also thank our director for giving me the responsibility, and I think I thank for each and everyone, and with this I will close my talk. Thank you.
Thank you so much, sir, for taking us through the vibrant tapestry of engagements. It's a true reflection of SERC's commitment to excellence. I now request our Chief Scientist, Dr. J. Rajashankar, to introduce the esteemed chief guest to the august audience.
Yeah, very good afternoon to the dignitaries on the dais and family members of SERC, the senior colleagues. I'm just very happy, thrilled to see every one of you today. I just can't, I can name each one of them, but to want of time, I am restricting to see every one of them and addressing you as a family members, well-wishers of media. It's a very, very nice afternoon for all of us today. It's a momentous occasion, the day, 6 years before the institute was started. Now, to add value to this occasion, we have our chief guest. My role is restricted to introduce the chief guest to this audience. Before reading out this 1 or 2 page biodata, and before going through this, I can tell you that this is a very decorated person, professionally, academically, and industrially also. And let me go through the details. It's a very loaded biodata. Professor U. Kamachi Mudali is a Vice Chancellor of Homi, Bhabha National Institute, Department of Atomic Energy, Mumbai. He's a globally renowned materials and corrosion specialist, well known for his pioneering contribution over 42 years towards the development and deployment of advanced materials of coating technologies for aggressive corrosive environments in nuclear and allied industries. And just to illustrate it, he has been the fellow or honorary fellow of more than 10, to be exactly 15 academies, like including engineering fellow of Indian National Academy, Science Academy, and so. And he is a distinguished alumnus of both IIT Bombay and PSG College of Technology, Coimbatore. Professor Mudali joined the IGCAR, that is Indira Gandhi Center for Atomic Research, and served there till 2017, metals and chemistry and metals fuel cycle. And he was the distinguished scientist, chairman and chief executive of Heavy Water Board, Mumbai, from 2017 and superannuated in September 2020 for a long of 3 years. And subsequently, he was a honorary professor of practice at IIT Madras for a year, that is 2021 to 22. That is, from industry, he switched over to academics. And then he became Vice Chancellor of BIT Bhopal University in 2021 to 23 for 2 years. Then Professor Mudali's research interests are evident in his 477 journal papers, 25 edited books, 6 patents, and 336 invited presentations. As an outstanding researcher with 14,270 citations and H index of 56, and I index of 315, Professor Mudali has salvaged several chemical, nuclear, and allied industries on cost-saving and production-oriented corrosion-related problems. Further, he has guided or coordinated more than 150 UG, PG, or PhD students for many academic institutions. He's a wonderful teacher, must be, a guide also. And driven successfully 21 R&D projects under industry-academia collaboration under his tenure at IGCAR. Professor Mudali is an adjunct professor of Institute of Chemical Technology, Mumbai. I think he's currently also, sir. You are a adjunct professor and also distinguished professor of eminence of PhD Institute of Advanced Studies, Coimbatore. Dr. Mudali is recognized in the world's top 2% scientists from India in the field of materials and is decorated with many distinguished recognitions. To name a few, I list out: Lifetime Achievement Award from the Ministry of Steel, Government of India; Electrochemical Society of India, Bangalore; National Corrosion Council of India, Karaikudi; Rotary International District; G.D. Birla Gold Medal, Platinum Medal from IIM, Indian Institute of Metals; Gold Medal from Indian Nuclear Society, Society for Materials Chemistry, and so on. So it goes on. I'll just mention only the highlighted points. Homi Bhabha Science and Technology Award from Department of Atomic Energy, and Metallurgist of the Year Award from the Ministry of Steel, Government of India. And NACE, that is National Association for Corrosion Engineers, International USA, has honored him in 2019 with the prestigious International Frank Newman Speller Award for his outstanding contributions to corrosion engineering, which is the highest recognition, and he is the first person from India to receive this award and this recognition. Further, he is a fellow, Professor Mudali is a fellow of ASM, International USA, NACE International, and so forth. And he himself has, after quoting few, he said it is, and 10 more professional associations in India. He is the chief editor of Journal of Electrochemical Society of India, editor-in-chief of IIM Springer book series and CIA Corrosion Management Committee. As a visiting scientist, Dr. Mudali has traveled to many countries, including USA, Germany, Russia, France, UK, Japan, China, Malaysia, Israel, Bulgaria, Canada, and Singapore. And Dr. Mudali is the chairman of Corrosion Management Committee and Division of Confederation of Indian Industries, and has organized more than 50 training courses and has trained 3,000 plus corrosion engineers and managers in India and carried out corrosion audit, survey, inspection, and failure analysis of Indian industries. Dr. Mudali held leadership positions in many responsible government and professional societies and organizations, including the president of the Indian Institute of Metals in 2019 to 20, chairman of Niti Ayog's Strengthening Recycling of E-Waste Committee, MTO 24 Sectional Committee on Corrosion Protection and Finishes of BIS, High-Level Expert Committee for Minor Specialization Nuclear Energy of the AICTE, trustee of in ASM International USA in 2021 to 24, president of both Indian Institute of Chemical Engineers Mumbai Regional Center and Electrochemical Society of India in Bangalore. I just want to conclude, sir. Thank you very much for accommodating and accepting our request to come here and deliver this Diamond Jubilee Chief Guest Lecture. And he's going to talk about relevance of corrosion towards towards integrity and management of structures. Over to you, sir.
Good afternoon. Honorable Director of CSIR-SERC, Dr. Anandavalli, other distinguished guests on the dais, Dr. Prabhakar, Dr. Raja Sankar, Dr. S. Parivallal, Dr. Ramji Singh. I am seeing many distinguished professionals in the audience side. Professor Santosh Kaparia, I am seeing him after a long time. Very happy to see you, sir. Professor Ravindra Gettu here, Professor Sekhar, and many other distinguished former employees of CSIR-SERC who have assembled here for the Diamond Jubilee celebration. The current employees of CSIR-SERC and their families, invitees, students, I see many young students and scholars here. And ladies and gentlemen, I am extremely delighted. I am pleased that Dr. Anandavalli invited me to this mega event, the Diamond Jubilee celebration of SERC. I also have, my memory goes back in 1990s. I used to visit along with my mentor, late Dr. Baldev Raj. I used to come with him to SERC. And he would come here to interact with the structural engineers related to, introducing non-destructive testing to monitor the degradation and the structural issues. So I used to come here. I was also interacting with Dr. Mani. He was in SERC and he conducted a course on concrete degradation. I attended the course also. It was about 4 or 5 days. And very long interaction. In the same auditorium, our IGCAR programs were conducted twice. I was here and I was very fondly recalling my association with SERC. And I am delighted that Dr. Anandavalli called me here for this occasion. I am also very proud to tell you that everything that you achieve, everything that you get in your life, maybe it's a very long biodata, they would have shortened it to suit the occasion. It all comes through hard work, comes through your persistent, contribution to the scientific society, and also you should have lucky to have very good mentors. I was very fortunate to have very good mentors over 42 years of my service in the Department of Atomic Energy. And my association with the subject corrosion started in 1982 when I was doing my master's in material science at PSG College of Technology. I had a very passionate, great teacher, Professor O.P. Vidyakar, who taught corrosion science and engineering and also gave a small project, and that was setting a passion or interest for me on the subject corrosion. Subsequently, I did my M.Tech corrosion in IIT Bombay. Then I joined IGCR Kalpakkam, and I worked there for about 34 years. Then I moved to, I can tell in a lighter way that before I moved from IGCR Kalpakkam, I was also shortlisted as a candidate for one of the prestigious CSIR lab, but my department woke up, but I was promoted and shifted to Mumbai as the chief executive and chairman of Heavy Water Board. That was a very high position with 7 industrial plants operating and producing all strategic materials for the Department of Atomic Energy. Then I served there 3 years, and subsequently I was there for a short time in IIT Madras, and then VIT University Bhopal. I was there for 2 years. Now I am in my own department, called me back and appointed as the Vice Chancellor of the Homi Bhabha National Institute for 5 years, and I am very proud that I am able to serve to this department and my country. And also I am very proud today that I am invited to deliver this Professor G.S. Ramaswamy Memorial Lecture on the CSIR-SERC Diamond Jubilee celebration. And as it was mentioned, the topic is on the relevance of corrosion towards integrity and management of structures. And talking too much about structures here is like selling coal in Newcastle. I don't want to do that. I will be going through my journey about corrosion, that why corrosion is relevant and what we can do to take care of the integrity of the structures as India is growing. And we all know very well that our country is now placed in the 4th position, just last 2 weeks before the 4th largest economy in the world. And we are trying to now competing with Germany. Maybe by end of this year or beginning of next year, we will be also crossing 4.84 trillion US dollar GDP, and we will cross Germany also. And subsequently we are in the 3rd place, and we will be only competing with China and USA. And our growth rate today, as you see, that growth is now happening, that going towards 2030 to 2050, you can see that India is the only country that can have a positive growth rate. And today it is around 6.5 to 6.8, but it is not going to be, very, very less. It is going to be 3 to 4% or 4 to 5% in the next 50 years. And this is the great thing that is happening in India, whether it is roadways or highways or agriculture or aerospace, power, construction, railways, any domain you take, India is now under construction and India is now growing. And if you go abroad, later when people say India is IUC, India under construction, that is what is the terminology by which people mention as India. And we have a very good roadmap for the Indian industry to produce affordable clean energy, to have transportation logistics, to have housing and water supply for everybody. Digital services, we are now globally competing with in any other country. You can see that digital services are one of the best in in the world. The quality education and the agricultural sector, healthcare sector, and the sustainable and smart cities, that this government is giving a lot of importance to this. And if you look at This is all happening because the whole world is today working for the sustainable development goals, because sustainability is a very important terminology that is looked by everybody, because we want to make this world a better and sustainable one for the future generation. There are many goals, 17 goals. Each one of them has some targets. There are 269 targets. But what is very important as a material specialist, I see that many of them, like the healthcare or the clean energy and industry, the sustainable cities, the industrial growth or climate action, if you look at many of them, they are all connected with materials. So materials play a big role towards sustainable development. And today, if you look at climate change as a big role with respect to controlling the CO2, where material plays a very important role. Conservation with respect to energy, with respect to anything, resources, material plays a big role. Clean energy, material is very, very important. Even you go to any renewable sector, the development of material is very, very important for that purpose. The healthcare sector, mobility, any sector you take, the materials are very important, and without material, you cannot achieve anything, and any important topic has a fallout or impact on the materials. So there is various demands, increasing demand for various metals and materials in very large quantities. Any sector that you take, whatever I have mentioned, climate change or conservation, clean energy or healthcare or mobility, materials play a major role. So metals and alloys and materials are required in large quantity. And this is also important, as we know that the population is phenomenally growing. Today it is around, going to be predicted around in the next few years 8.5 billion, and we have just crossed, I think, 7.5, 9.8 billion by 2050, and 11.2 billion by 2100. So increasing demand for materials, increasing demand for everything for sustainable development is very, very important today. And all the assets and infrastructure that whatever we know that is being made of metals and alloys and materials, they have limited life. They do not serve forever, and they undergo failures, they undergo wastage, they undergo all kind of degradation mechanisms. So we need to extend their life. We need to see that they perform to their fullest life and beyond their life by extension with useful properties and high performance. That is the real concern for the sustainable development. As much as we are going to use more and more service of any asset, any infrastructure with the same materials, the metals and alloys that is available today, we are not going to deprive the future generation with all those precious metals and alloys. So that is where that we have to extend the life of the existing structures. We have to have high performance of whatever that we have today. But all that will be difficult to have. All metals and alloys which are not present naturally except gold and platinum, they all come from their ores and compounds as a in a stable state. We take the metals and alloys from these ores and minerals, so they are all in a metastable state. They have to undergo corrosion, which is a naturally degrading process. And no metal and alloy can be protected forever, cannot be allowed to work forever except gold and platinum, because all of them will undergo corrosion, which is a natural thing. And if you want to have any asset, any structure to have an infinite service, infinite integrity, we need to take care of this corrosion. That is where that passionately I have been pursuing this subject corrosion for a long time. But all that will come into the mind of the younger colleagues who are here, that why these metals and alloys should corrode, because all that metals and alloys, they have been taken out from the minerals and ores after spending so much of energy by melting and refining and making alloys and making all the products. Why that it has to undergo corrosion, and why that it has to lose its property, why that it loses its service? Because all these metals and alloys are in metastable state, they interact with the environment. If suppose let us take iron, it starts its journey as iron oxide, the hematite or magnetite or ferrite, and from there we take the iron and then we make steel, stainless steel, and make all the products. So all these iron, steel and stainless steel, they are all in metastable state. They are hungry to react with their counterpart in the environment, that is nothing oxygen. So they try to form iron oxide, that is what is rusting, and rusting is the most common with the steel. We try to add further alloying elements, improve its property as alloy steel or stainless steel. But ultimately, they all interact with the environment and they undergo corrosion. They give up all the energy that has been introduced during the production of the metals, the manufacturing of the components, and they become a scrap or corrosion. So that means they go back to their original state of rust, that is iron oxide. So it is a cycle that is always followed for all the metals and alloys. And you go to any industry, you will find 90% of the components are made of, iron and steel. And to this, the next available only metal is aluminum, which can be used for any structural application. Otherwise, wherever you go, you will find only the ferrous materials are used. So it undergoes rusting. So we try to protect it and extend its service. What is that we do? We do simply painting, we do some coating, we do try to use some better alloy. Suppose iron is corroding or steel is corroding, we try to use alloy steel, we try to use stainless steel, and so on. So why this corrosion phenomena is happening? Because of various factors that are affecting. One is the properties of the metal, another is the property of the environment, and third one is the interface that is developed between the metal and the environment. There are so many parameters, like starting from the nature of the metal, the environment and its interface, the surface, the oxide film, the nature of the product that is formed, the temperature, pressure, pH, and the oxidizing or reducing ions that are present, even the humidity of the air, all this will be affecting the corrosion of the metal and alloy. And thus it is a very complex subject, it is an interdisciplinary subject, and every one of us try to be, being very allergic to this subject, because any chemist will not understand much of metallurgy, any metallurgist will not understand much of the chemical engineering or chemistry. And if you are with the civil engineering, you should know the metallurgy of the steel, the rebar, or any structural component, or you also should know about the chemistry of the concrete, chemistry of the species that are intruding into the concrete, chemistry of the products that are produced during the service life of the concrete, or the concrete steel interaction that leads to the degradation of the structures. So, very complex subject that leads to lot of issues with respect to promoting the subject corrosion. So, all metals and alloys are, in my opinion, frozen chemicals. They are always hungry for interacting with the environment. They undergo from their metallic state to the corrosive, the corrosion state, the metastable state, and then they form a stable state of the compounds. So what is the impact? Let it corrode. Why we have to worry about the corrosion? Corrosion has major impact in the 4 different titles I have given. One is the product impact, second one is the safety impact, third one is the societal impact, and fourth one is the economic impact, which is comprising of all the 3 above. Let us all recall in December 1984, there was a Bhopal gas tragedy. One of the chemical plant with them, where methyl isocyanate was produced in a stainless steel vessel, it got corroded due to an unfavorable chemical reaction that has happened, and this led to the explosion, the release of few tons of such gas that is coming out from the factory. And you all know that instantaneously thousands of people died in Bhopal and lakhs of people were affected, to generations of people. Even today the case is in the court and nothing could be done. So much it has got a problem with respect to, not only with respect to the product of the factory because it was closed down, but also the life that is lost, and then the safety of the public, and then finally the economics. So all the industries which will have the chemical processing particularly will lead to the product impact, the safety impact, the societal impact, and economic impact. Somebody can question that how much will be the economic impact. Look at the statistics available today. The worldwide cost of corrosion that is happening is about 2.5 trillion US dollars, 2.5 trillion US dollars. It is almost, today I would say India's GDP is 4.19 trillion. We are fourth largest economy. You can say more than 50-60% of our GDP is the world's corrosion cost. And this is considered to be about 3.4% of the GDP of the world. And now if you take for India, it has been estimated in 2016, 4.2% of our GDP, because we are not that much industrially advanced country, 4.2% of GDP is lost due to corrosion phenomenon. And if you estimate in 2025 today, 4.19 trillion is our GDP, and this 4.2% of this is about 176 billion US dollars, and that is 15 lakh crores of Indian rupee is lost every year. It is only because of the corrosion, which is leading to product impact, safety impact, societal impact, and economic impact together. So it is not that just something rusting that you can ignore it or just paint it and leave it. It is something that is significantly affecting the economy of our country. 15 lakh can be the annual budget of 2 or 3 states of our country, so we cannot just ignore it. And if you look at further details, I am not going to present here, that utilities have 35%, infrastructure has 16%, government 15%, government structures, assets and infrastructures. The product and manufacturing sectors 13%, transportation sector including air, land and sea, that is 21%. In reinforced concrete is going to contribute about 50% of all this, the cost of corrosion that is happening in all these sectors. So that is where that corrosion of the structure, particularly the reinforced concrete, has to be given a significant importance, and I am sure that is being given all over the country, and I am very proud that CSIR-SERC is leading in this regard. If corrosion is happening, if we are going to have significant economic loss, monitoring of corrosion is one of the very important things. So once something started functioning, whether it is a chemical industry or energy or a power plant or whatever it is, monitoring the corrosion that is happening is very important. And this year $3.5 billion was spent in 2023, and $8 billion will be spent by 2031. About 10.9%, that is 11% of annual growth rate is happening with respect to corrosion monitoring. So you can understand how much is this phenomenon that has to be monitored in this country. Not only that, the corrosion research is also given a prominent role in all the research labs, not only in our country but also worldwide. The basic and applied research, coatings and new surfaces, sensors, probes and devices, testing, various testing and detection and monitoring technologies, and modeling and life prediction. Today with AI and ML technologies that are available, more and more modeling and life prediction is going on, so that we can understand the remnant life of the structures and we can take methods for extending their life. So we have to not only understand or update our existing knowledge, but we have to also develop with the developments that is happening worldwide in corrosion science, engineering and management. Just a glimpse of why we have to give importance to structures and infrastructures. The global investment in infrastructure is predicted as 94 trillion by 2040. This was estimated in 2016. And additionally, subsequent to this introduction of Agenda 2030, the introduction of Sustainable Development Goals, 3.5 trillion is required to meet this SDG. So totally it is going to be 97.5 trillion, almost $100 trillion will be spent on the infrastructure between 2016 and 2040. And 50% of this infra investment is going to be in Asia, and India is going to be the leader in this. India is going to spend about 4.5 trillion till from 2025 to 2030 in order to realize from 4.1 or 4.2 trillion to 10 trillion economy by 2030. So it is very, very important that we give importance to corrosion management of structures, not only the existing structures, but also the new concrete structures. Because the collapsing of the structures is one thing, and systematic and time extended failure of such structures also another important thing. So this is happening, I think, as all of you know, that the damage level of structures with respect to the exposure time as aging takes place, it is, initially you have some time for the chloride or any other corrosive agent like the carbonation or the oxygen, moisture, anything to enter into the structure through the cover layer. It takes an inhibition period, the initiation period. Once it reaches the initiation period, the diffusion gradient that has been created, the concentration gradient that is generated between the surface and to the interface of, let us say, the rebar or the steel structure inside the concrete, it accelerates the propagation stage where the corrosion cracking starts, and then that leads to more and more diffusion, more and more penetration of corrosive species. And what happens, this is the phase that some of the structures that has been constructed in 1980s and 70s, which are now 50-year-old, if you look at the Western countries, they are more interested in the aging structures because most of their structures were built in 70s and 80s. India is now today, as I said, it's IUC, India under construction, we are building so many structures. So we are interested in further, beyond the provocation, how are we going to, take care of the structures. We also have limited aged structures, particularly those structures in the coastal, area. India has about 7,500 kilometers. Now that is revised to 11,000 kilometer coastal line, and the availability of chloride, the availability of moisture, oxygen, and the relative humidity fluctuation leads to highest, penetration of chloride that is leading to the aging of the structures at an early stage. So we need to, the structural engineers and the corrosion specialists have to work together in order to see that the structures, not only the structures that are going to be constructed, to be given importance for this, the existing structures, the old structures of 40, 50 years also has to be given very important consideration with many technologies. Indeed, during my service at IGCR Kalpakkam, we have been working on the extending the life of the nuclear power plants. Most of the power plants, nuclear power plants in the world, they work up to 30 years to 40 years, and we have been trying to extend the life of our reactor from 40 to 60 years. And you will be happy to know that the Tarapur atomic power station, the power plants are operating more than 50 years today. It's the world's longest operating power plant in Tarapur. And we have been thinking that the power plants at Kalpakkam also should be extended, beyond 50, and it should reach at least 60 years. But the limiting point of operating this, the power plant at the coastal side, it is not the power plant components. It is one of the important thing, but what is the thing is the availability of the concrete structures in the coastal side. So you have to have condenser to continuously to operate for the power plant. The condenser is completely with the coastal, infrastructure, concrete structure that has to be, have more than 60 years. So for future reactor, we started working on 100 years life for concrete. So that is where that, new structures we should target to work for 100 years. And the existing structure, we have to find way and mean to extend their life to 60 years and 80 years and 100 years and so on. So as I said that there is a big construction boom that is happening. The construction boom is happening across all, whether it is rail lane or airways or the shipping or smart cities. Today India is the second largest road network next to the US, and I hope that we will surpass US also within few years. We are fourth largest railway network, 65,000 kilometer railway line, and government is introducing many new lines and enhancing its performance. Also, we have 1.7 lakh bridges, and already we have identified more than 6,000 of them are super stressed or stressed that they have to be looked into maintenance for maintaining their life. And maintaining this existing infrastructure and building the new one with durability and corrosion resistance is the need of the hour today. And I think for the benefit of the young students and the scholars here, that if corrosion has to happen in concrete structure, the essentials are the moisture, oxygen and chloride. And chloride and carbon dioxide with relative humidity, they assist the moisture and oxygen that can penetrate into the structure. And what we need is very important to avoid this corrosion is protectors like the cover that can be the cover of the concrete, the covercrete we can say, and the electrochemical methods to delay the corrosion that will happen, either the impressed current cathodic protection or the galvanic anode based sacrificial protection. And this chloride is the most deadliest thing that will lead to significant degradation of the structure. If it is a marine and coastal environment, as I said, it is the fastest and quickest one that will happen to corrosion. And if it is something that we are using the saline water or the beach sand or the chemical admixture which has chloride, it is also going to assist the corrosion that will happen quickly. So it is irrelevant whether it is a building or bridge or chemical plant or any structure. Chloride is the most deadliest ionic species that will lead to the degradation and corrosion of the concrete structures. And this is the CSIR-SERC's corrosion map, where they have identified the different levels of corrosion with respect to the chloride content as well as the corrosion weight loss, weight gain method. And they have identified from extremely severe to negligible corrosion rate. You can find that most of the coastal site, wherever you have structure, naturally that it will undergo significant corrosion. So the quality of the material that is used, whatever may be, you will find repeatedly they are undergoing, whether it is in the seawater or it is in a dry atmosphere in a urban or it is in a typical chemical plant, corrosion is a cancer and it penetrates, and once it starts, it continue to grow and nowhere that you can stop it. You can only delay it. You can never stop corrosion in failing your component. And all of you know that the repair and strengthening of the structure is done either due to the change in the application or use, or due to deterioration, or due to faulty construction that has been carried out, or the structural damage that happens due to the service problems. I am very interested in the deterioration that happens due to corrosion, because corrosion also will lead to loss of section, cracking and failure, and it cannot be stopped. As I said, it will continue to grow. And today it is predicted that 1.41 billion meters square of concrete is available, at least this is about 1% of the concrete volume that is available for repair in the near future in our country. So we need to do significant R&D towards corrosion control of structures, and there are many things that this itself can form one lecture. I am just giving only the idea that is already being pursued probably in your own institute, developing concrete with very high resistivity and very high resistance for corrosion, and developing also concrete with corrosion inhibitors, and also adding some inhibitors to the steel that is going to be put into the reinforced structures. Coating for steel reinforcement, and today you find that most of them recommend different types of starting from the epoxy to cementous to galvanized to many, the graphene faced coatings are now current topic, people are working on that, and the durable coatings for concrete itself, so that you can avoid the penetration or diffusion of the corrosive species like chlorides, carbon dioxide, oxygen and moisture. Non-metallic reinforcement, why not go for the polymeric or the reinforced polymeric polymeric reinforcements. And of course, if it is an existing structure, R&D should be done to introduce cathodic protection by impressed current cathodic protection, or using durable high performance anodes either in a sacrificial or in an impressive mode. And we also need techniques to understand the parameters of the concrete when it is in service. One is the mechanical parameter, another one is the durability parameter. The mechanical parameter, various tests are available, and the durability parameter, you have large number of testing parameters, and all these testing parameters provide complementary data so that one cannot get a complete picture about the degradation with one single data. One has to have the synergy of many techniques to have a holistic view of that. Ultimately, what we have to do that any of these techniques, either used in single or in complementary manner, we have to have a balanced approach to have the quality of the cover crete, that what we call the cover layer, and the steel that is inside should have an excellent performance to have a longer life for the structures. I just give you few examples that how it is being today used all over the world to monitor the existing structures. Some of the concrete imaging and scanning techniques that have been used all over the world, like the ground penetrating radars, the ultrasonic imaging and tomography, that is the number one that is being used widely in all the structural inspections, the electrical resistivity and X-ray imaging for limited applications, and half-cell corrosion mapping. It is like a screening test. It can be used instantaneously with limited training. And I give you some examples of how it is being applied for locating the steel rebar, or to determine the thickness and locating the delamination in a deck, and also identifying locations with a higher likelihood of corrosion by half-cell corrosion potential mapping. Half-cell corrosion potential mapping is the simplest technique that has been used widely, and this gives a map of the fluctuation of the corrosion potential if you are able to do it in a mechanized way or in an automated way, and the delta difference of the potential, what you see in the picture, the red color, dark red color that you see in the pictures in the map is the one that is undergoing significant corrosion, where it is far away from the corrosion potential. And you can do it for limited structures like the beams and smaller structures, or to even a very large area, floor area, where you want to understand how the whole area is getting corroded with the measurement of the corrosion potential. And people today start using the automation. They use the robots. The robots are being used for large scale measurement of real life, like the bridges and so on. And apart from this potential mapping of various type of structures, today people also use the sensors. Either the sensors are introduced either in the structure before it is being made, or it is being introduced as an additional step during their service. And these sensors provide instantaneous continuous parameters like the current density, the resistivity, temperature change, or the chloride ion penetration. And you have to, once you know the chloride ion is there, it helps you also to effuse them out so that you can avoid this chloride reaching the interface of the rebar or steel structure with the concrete and further corrosion. And introduction of this sensor devices, people also try to develop some smart devices, something called the triboluminescence camera with some chemical compound that will be sensitive to the cracks that are present, and by emitting lights has been also has been done by CSIR-SERC some time back. And there are many bridges today which are they are called the smartest bridge. These bridges introduce the continuous monitoring devices, not only for corrosion monitoring but also vibration monitoring, for fatigue monitoring, for temperature monitoring, and the strain gauges with respect to the strength monitoring. And this helps, this is a model bridge across the Mississippi River in the in United States of America, where even today this measurement of the weather condition, the vertical and the horizontal movement under traffic conditions, the temperature fluctuations, and the corrosion potential variations, all that is being measured in order to understand the instantaneous the degradation that is happening in the bridge. So we need to have various solutions for mitigating the corrosion of the concrete structures in construction stage as well as post-construction service stages. This is all I think all of you know very well. It's a textbook matter, and ultimately all these methods have to be applied starting from the choosing of the concrete and the steel that you are choosing as a rebar or as a structural material, the admixture if you want to choose as an inhibitor for concrete, or you want to use some coating, surface applied inhibitor on the surface of the concrete or the steel. Protective coatings, various types of coatings that we can apply, and of course the cathodic protection for the coastal structures as well as for the structures which are loaded with more number of the steel or the rebars. So we can also do the combination of these techniques. I am not going into detail. All of you know very well that we have to protect corrosion of the concrete structures by employing all these corrosion mitigation techniques. If we can do all this generally for any infrastructure, for any industrial asset, we need to have better material, we need to have better design, and for the corrosion management and prevention and control. And this will also required for the existing structure. We have to do life prediction, we have to do life cycle performance and assessment of the present status of the material or the corrosion behavior. We also now today try to introduce innovative corrosion technology tools like the introduction of the AI ML techniques, the unmanned aerial vehicles, robotics, the sensors, various sensors, and the most important thing is to bring in an awareness and large corrosion cost and potential saving to the stakeholders and policymakers. And we should also make all the industry people to believe that R&D and academia can do something that always to control the corrosion. This faith and the confidence that academia should have and the industry should have on academia and R&D, that will only help us to do innovative research in the future. With respect to the societies and various agencies, we should go to the government for having improved policies, changes in the regulations and standards and management practices. This is very important to introduce additional corrosion technology and management so that we can save money. And not but the least, we have to do the education and training in corrosion control and prevention to all people in the organization, including the top management. Sometimes the training, the teachers and training the workers is very important, but we have to also train the management, the top executives, because everything starts, corrosion management starts from the top. In India today, I am very proud to tell you that there are various institutions, various organizations and societies. They are all trying to do this corrosion management. And what we do in fact is the exact corrosion cost estimation with new methodologies. This is one important thing. We are still following what has been decided, what has been discussed and made by the United States of America, the NACE International, or the Association for Material Protection and Performance, AMP. We have to have our national corrosion cost estimation with our own methodology for our own climatic tropical conditions. We should have established corrosion control guidelines for each sector. We have 10 prominent sectors where industry is growing today. The phenomenal economic growth is happening. We don't have sector-wise corrosion control guidelines. We need to do also corrosion survey, audit and accounting in all industries. Very small way this is being done. That is where the faith and hope of the industry is not lying with our academia and research. And establish guidelines to implement online corrosion monitoring for very focused plants where corrosion is very important is also to be done. And R&D has to be also introduced in thrust areas for finding of new corrosion control methodologies to achieve savings in economy, energy and materials. I am very happy that CAI, FICCI, various IITs, professional societies, they are all now doing a lot of corrosion awareness programs, and they are imparting education and training by all stakeholders. I am very proud that many CSIR labs like SERC, SECRI, NML, IIMT, many are doing such programs. And today I am just going to tell in few slides before I conclude that there is an effort made by the CII, the Confederation of Indian Industry, to have a national corrosion mission and a policy to establish a Bureau of Corrosion Control. This corrosion management committee and division was formed in 2017 under the leadership of late Dr. Baldev Raj, and today I am the chairman since 2019, and we have about 100+ national corrosion experts, And this management of this corrosion management division is done by an advisory council, and I am very proud to tell Dr. Anandavalli is one of the expert member in the advisory council, and this council has established a national mission. It was declared in February 2023 in presence of Dr. Saraswat, V.K. Saraswat, honorary member of Niti Aayog, and there is 7 action-oriented task forces are there under this corrosion management mission. And I am very proud to tell under this mission we have done corrosion survey and audit in 22 industries. We have done 70 plus training programs and nearly 2,200 organizations and 3,000 plus managers and engineers have been trained so far. 26 booklets on corrosion management has been established and many other aspects for benefiting the industry. Continuing education program in jointly with IIT Roper, CAI is conducting a postgraduate professional development program for corrosion management and technology, and with support of the Ministry of Steel, a national policy on corrosion control and management is being established. I am very proud to tell on 8th May 2024, a policy document was submitted to the Ministry of Steel by us, and this policy addresses the challenges of corrosion damage and losses, and it also gives way for strengthening the sustained collaborative effort between various agencies to control the corrosion and to have a resilient and corrosion-free nation. And various strategies have been discussed which are very practical, scientific and implementable. And some of them are that to have a joint task force by Ministry of Steel, CAI, CMD and other stakeholders. And second thing is to have an Indian Bureau of Corrosion Control through public-private partnership model, and to have a corrosion prevention and development fund with a corpus of 200 crore from Government of India to initiate innovative R&D projects in all those sectors, 10 sectors where the economy is growing today. And finally, Ministry of Steel should be a nodal ministry to do this. And this is the policy document that we have submitted for 7 sectors, and one of the important sectors that we have given various strategies is the ABC, architecture, building and construction, which takes care of the structures and infrastructures. It takes care of urban and rural infrastructures, residential and commercial buildings, industrial and public infrastructure, and heritage and monument conservation. And the key statistics that we have submitted today, that market size is 1.4 trillion, which is expected to reach 3 trillion by 2030, which is today's GDP for the ABC, the architecture, building and construction. It is growing at a rate of 7 to 8% annually, and it is contributing to GDP about 9 to 10% today. And the employment generation in the ABC sector is approximately 60 million people by 2030, and smart city investment by government in this sector is 2 lakh crore. And this is these key statistics. And we are also some of the parameters that we have given to government to justify that why this policy is required for architecture, building and construction. And this is because India's estimated cost of corrosion in the ABC sector is estimated to be roughly 1 lakh crore. Out of this 15 lakh crore, the entire construction sector accounts for 9% of the GDP, and the bridge and infrastructure maintenance cost today is 15,000 crore annually, and of course the repairs of the affected buildings, the existing buildings, is about 20 to 25% of the construction cost over 50-year lifespan. So we have submitted this policy, and some of the gains that is expected from the policy, which is under study by the Government of India. They asked further some white paper on supporting document on this policy that has been prepared, and this is going to be submitted to the government. The gains that we will get is that if we are going to introduce this policy, the corrosion losses, what I have told in the beginning, that 15 lakh crore by the 2025 this year, it will be reduced in 3 years by 20%, by 2036 by 30% after 8 years, and by 75% by 2045. And that means the saving is about 40 billion in 2028, 120 billion in 2036, and 600 billion in 2045 as per the estimation that we have made in the white paper. And not only the physical saving of the assets and the structures, but also the financial resources, will lead to the capital asset and reducing the cost of the maintenance. The reduction in the maintenance and accident related shutdown will definitely improve the productivity once the policy is implemented, and the cost of replacement and maintenance will be substantially reduced with modern introduction of modern anti-corrosion product and practices as recommended in the policy. And there will be improved level of safety because of the policy is advocating more and more innovative features in the industry and infrastructure operations. We will have a cleaner and safer working environment. That means the green fund, the FDI and regular investment from the foreign investors will keep increasing due to this. And ultimately, it will give a lot of skill development and employment, and we will be able to manage our own structure and assets by having our own policy. So I am happy to now close my lecture. That understanding and contributing, to the controlling of corrosion, not only to the new structures that are going to be built, but also the useful life of the existing structure is very, very important towards sustainable development, so that we are maximizing the resources, we are utilizing the already existing structures in the infrastructure to its fullest, efficiency and service. And secondly, that there will be a long-term strategy once we implement the corrosion policy. Once we are going to find way to have this sustainable development, we can also find way to go for long-term, strategy with respect to material resources, reserves, and applications, so that the life extension, the life cycle management of structures can be, very effectively taken care. So this white paper until 2100 it needs to be prepared, and it is in the process of being done by the committee. And we should give a lot of importance to the corrosion damage, which is colossal in nature. It is the biggest concern with respect to any asset and structure. You put all your effort and you put all your economy, you put all your time, and we need to, take care of it also during service. But for this corrosion damage, if we can take care of it, India as a country will grow, and it will grow significantly, by saving significant resources and economy. And I feel that this national policy and having a institution for the corrosion, Bureau of Corrosion Control, will help, to make our assets and structures corrosion free. If not, completely zero corrosion, I cannot say that. It will be corrosion free during its entire life cycle. Thank you so much for giving me an opportunity to present this lecture here.
Thank you, sir, for the thought-provoking lecture on corrosion, highlighting not only where we stand, but also what we have to do in the future. Now, we move on to the next lecture by the guest of honor. Before that, I now invite Dr. S. Parivallal to formally introduce our distinguished guest of honor.
Good evening to everyone. So it is a special moment for CSIR-SERC family members to celebrate the glorious 60 years of our organization in the service of science and technology. It is with immense pleasure that I introduce our guest of honor for Diamond Jubilee celebration of CSIR Structural Engineering Research Center, Dr. Ramji Singh, a stalwart in the field of hydraulic engineering, dam safety, information technology, and public infrastructure governance. Dr. Singh brings over 30 years of multidisciplinary expertise and a truly global perspective. He holds a doctorate in IT and data management engineering from International University of Paris with additional advanced degrees in computer engineering, IT, and management. Dr. Singh currently serves as a senior member of Dam Safety Review Panel under Government of Gujarat and a national level technical advisor. He plays a critical role in shaping strategies for dam safety, hydropower generation, canal automation, SCADA and IoT-based monitoring system and cyber forensic governance. He has led over 140 major dam inspections and 240 plus evaluation of water retaining structures across the globe, covering projects ranging from small hydropower unit to massive 1200 megawatt installations. Dr. Singh's exemplary work has earned him prestigious accolades, including CBIP Award 2024, the International Excellence and Global Leadership Award in Malaysia, and the Dam Safety Excellence Award consecutive 2 years in 2023 and 2024. He is a prolific author with over 150 publications, and his books such as Reservoir Mapping, a complete guide, and Scoring critical infrastructure with SCADA systems have been instrumental in advancing modern engineering practices. He is also a globally sought-after speaker and trainer, having conducted over 90 expert-level programs worldwide on infrastructure resilience, emerging technologies, and smart water management. Dr. Singh affiliated with organizations such as Indian National Committee on Large Dams, International Committee on Large Dams, ISA, CSI, and Dam Safety Society, and continues to advise on national projects like the barrage project, the Kalpsar project, and World Bank supported DRIP initiatives. It is a privilege to have him with us today and look forward to drawing inspiration from his remarkable journey and insights. Thank you.
So good evening. I'll take only 10 minutes. So this was my once a question to my secretary, that why our civil engineers don't smile. So he said, because we are civil engineer, we are hardcore engineers, so we don't smile. No, we smile. I have seen my dams smiling when it is on full reservoir. So it's a smile time for we all, because we are celebrating 60 years of achievements of our institution. So ma'am, thank you for inviting me. I'm very honored to have on board, and also I salute my all to the people who are sitting over here, and also I thank your staff, your gardener, your driver, your what is called the person who is there at the guest house. So there are some people who is contributing direct, there are some people who are contributing us indirect. So I salute all direct or indirect people. But since morning we are listening about the problem. So my journey also started to CSIR, addressing a problem that was related to my dam. And fortunately, we had a presentation by what is called Saptasriji. That was during the Dam Safety Conference at Kevadia 2023. And I was surprised to know that I was looking for someone who is having the solution. That realized me that problems is a natural process of our life. If there is no problem, probably we will not be having here. So that problem to bring me to the solution, because we were changing the gates of our dam. That dam is probably 45 years old, and we came to a notification by government that if it is 30 years plus, this dam has already served to the nation, you can go and replace the gates. And it's a clear-cut guideline. If you read in Dam Safety Manual of the Central Water Commission, they have given a timeline, 30 plus, okay, you can replace it. But as an advisor to the department, I was having one query, that if there is someone who is about to live for more than 100 years. So can we make him that, okay, it is over, now you go back? So this is what IS do, administration people do. 5,000 divided by 5,000 people, but who actually need it, nobody think about it. But we as an engineer, we always analyze where, what, why, who, these all question comes in our mind. So what I understand that CSIR have that potential, because when we are recommending any dam after the investigations or inspection, we are saying go for some of the investigations which are structurals, some of the investigations which are non-structurals. And there are many agency, startups, you can say people from different domain coming to our dam authority, and they are going for individual tests. Someone is doing geophysical, someone is doing UPB test, someone is doing some different test. But there is a problem that when we say correlate all those investigations, so nobody is ready for that. Correlate all those investigation result to the interpretation so that we can go for a proper rehabilitation plan. But that is, nobody is doing. If we say go for a stability analysis, people are coming, they are doing a stability analysis, but there is no solution they are giving. So what I saw, that this all in-house facility already CSR is having. So why not CSR can approach as a nodal link for that, because we have 12,400 dams across India. We are third largest dam keeper in the world. And as for the National Register of Dam, we have 6,400 dams which has to be rehabilitated before 2026. As for the Dam Safety Act gives the guidelines. So how many years we have, and still not more than 100 dams we have rehabilitated. And still our people from the dam domain, dam engineers, for them rehabilitation and repair is the same subject. But you as an engineer, being a civil engineer, you can better understand what is rehabilitation of a dam and what is repair of a dam. So I see a huge scope at CSR. See what is happening that if I quote example, one of dam in my state having some problem. So DSRP committee has recommended go for these tests. That was a UPV test, ultrasonic pulse velocity. And based on that test, everybody decided that we have to go and decommission this dam. Everyone is running here and there for decommissioning of dam, but nobody is reading that entire report. When things become larger, then it comes to the board or top advisory people. So when I was going through that report, I found that what is the approach they have done, what is the methodology they have applied. And I found that those who are from the testing industry, they can understand when you are doing something for your material test on the surface level, you have to first remove the cosmetic parts. Then you have to put some liquefaction items, and then you have to do. But when I went to the site, this was probably, it seems to be somewhere there is a deeper portion, but nothing has been filled. So that was one thing I observed. Another thing what I observed, that this dam is built in probably 90 years back. So the test report was compared with the M30. So that also raises, because that time M30 was not there. So this type of reports we are getting from the industry. Industry people are fine, they are good in NDT test, they are not aware of the domain. So that also brings me you, ma'am, again, because you have all those expertise. You have multidisciplinary, you have interdisciplinary, you have a single umbrella, you have all those experts in-house. Even those who are getting retired today, if you can make a biodata of them, we have some place where we can hire them as an expert. And we need like sir say corrosion, we are having the larger number of what is called canal network in Gujarat. And many places in Gujarat, you better know, there is a issue of corrosion because we have coastal areas. Civil body is perfect, but metallic body is completely corroded. We also need corrosion experts. We look forward to industry or some other relevant point. It is good that you have that expert also. So I see so many opportunity when I come to here, but there is some deficiency also. Ma'am, we are government departments. In government department, there is a subject called government process re-engineering. So our engineers, those who are coming from institution or industry, they don't know the government process re-engineering. I suggest you to hire government peoples who can teach them how process are being happen in government system. Generally what happens, industry try for 1 year, 2 years, 3 years, they finally get fed up. No business. But are you actually following the, what is the process there? No, they are not aware of process. So even this is my suggestion that whoever engineers are getting degree or PhD from here, we shall teach them what is government process re-engineering, so that dealing with the government will be the easy. And there are some lacking parts also from my department. Probably Tamil Nadu WID, one engineer is there. That we are totally disconnected from the academia or from the industry. We have a very poor adaptability. We don't adapt anything. Acceptance come with BIS code, IS code. We ask so many questions. Even we are something procuring from the foreign country, we ask IS code. So these are the challenges, ma'am. But what I understand that you have a huge setup. I have visited your few labs. You could believe me that in my dams, someone is taking core, someone is drilling, someone is testing, someone is interpreting. You have all those things. And besides this, we are paying crores of rupees for that. But result, again doubtful. So you have a credential, ma'am, also. So this will be my conclusion, that we shall look forward to the new domain, that is the dam. And you will face that problem because we have a water, what is called one type of policy there in India, that we cannot charge for water, we can only charge for the water facility we are providing to you. But coming age, probably this is going to be no more. So there will be nothing free lunch or free fabrics. It is good to be connected now, and there is a huge opportunity. What I am seeing as an expert to the department, not only to
Thank you so much, sir, for your inspiring words of wisdom on dam safety, a need of our country indeed. Time now to celebrate some sharp minds and quick thinkers. As a part of CSIR Diamond Jubilee celebrations, a quiz program was organized exclusively for civil engineering students with enthusiastic participation from 19 esteemed institutions on May 14, 2025. The top three teams emerged as winners and will receive cash prizes and trophies, while the 4th, 5th, and 6th place teams, the finalists, will be awarded trophies in recognition of their strong performance. I now request Professor U. Kamachi Mudali to kindly present the prizes to the winning college students, the young minds who participated in the Diamond Jubilee Student Quiz Competition. I now call upon the first prize winners from the second year civil engineering students of National Institute of Technology, Trichy, Mr. Amritansh Ranjan, Mr. Mohan Krishna, and Mr. Mohammad Yasin. Please come to the stage to collect your prizes and trophies. The second place is won by third year civil engineering students from Government College of Technology, Coimbatore. Due to unavoidable reasons, they are not joining with us today. We'll make sure the prizes reach them. The third prize is won by third year civil engineering students from SRM Institute of Science and Technology, Katangulathur. I call upon Mr. Manoj I now call upon Mr. Manoj and Mr. Sriram CM. You're from? Wait, just wait. So second is not here, sir. Next is third. Yeah. I call upon the third prize winners, Mr. Manoj and Mr. Sriram from third year SRM Institute of Science and Technology, Katangulathur. Big round of applause for the winners, please. Next, I request students from Meenakshi Sundarajan Engineering College, who are the fourth finalist, Mr. Saifullah, Mr. Pradeep. Mr. Saifullah and Mr. Pradeep from Meenakshi Sundarajan Engineering College, the fourth finalists. I call the fifth finalist from third year civil engineering students from Ishwar Engineering College, Ms. Parkvi, Ms. Mubashreen, and Ms. Harini to come to the stage. The fifth finalist to receive the prizes, please. Big round of applause for the winners. I now call upon the second and third year students from Dr. Mahalingam College of Engineering Technology, Pollachi, Ms. Karishni Devi, Ms. Ruba Darshini, and Ms. Subaranjana to please come to the stage. The sixth finalist, please come to the stage. Thank you, sirs. Just few minutes. On behalf of CSIR-SERC, we extend our deepest gratitude to our chief guest and guest of honor for their insightful and inspiring presence today. I now request our dignitaries on the dais to kindly present a token of our appreciation, a memento to our chief guest and guest of honor. Thank you so much, sirs. Thank you, ma'am. It's now to take a very short break. We are already running short of time, so I request everyone to reassemble in sharp 10 minutes so that we can continue with the rest of the program. The tea is served outside. Please reassemble in 10 minutes. Thank you. We are now moving on into an exciting and historic segment of our Diamond Jubilee celebrations. The next hour showcases a blend of our technological strides, our rich legacy, and our heartfelt tributes. We begin with the inauguration of Construct 3D Print Pod, India's pioneering demonstration of 3D printed concrete construction, conceptualized and executed by CSIR-SERC. I invite Professor Santosh Kapuria, former director of CSIR-SERC and a key champion of innovation of our institute, to inaugurate this marvel. May I now invite you to the dais, sir. To the center, if you can. Inauguration of Construct 3D Print Pod, 3D printed building in our very own campus. A big round of applause, everybody. Big congratulations to the scientists team and all the staff of SERC to making this happen.
So, good evening. I just wanted to share few thoughts about this project. So, this project was a niche creating project awarded by CSIR. I think this was during that time. This was the only project which was awarded for 5 years duration. Other projects were all awarded for 3 years. This was the only project with 5 years duration. And the highest allocation, if I'm not wrong, it is about 10 crore plus. So I really congratulate the team that they have actually, this was a dream and that dream has today come true. Thank you very much.
Thank you, sir. We now turn the page to a truly proud chapter, the unveiling of landmark publication that captures the spirit, science, and 60 stellar years of CSIR-SERC's journey. The release of Coffee Table Book, a curated visual journey of CSIR-SERC's achievement, and I request our chief guest, Professor Kamachi Mudali, to do the honors. Wait. A big round of applause for everybody. Next, we release the 60 Technologies book, a compendium showcasing the spirit of innovation, featuring technologies that have transformed structural engineering practice. I request Dr. Ramji Singh to do the honors. "60 Technologies for 60 Years of CSIR-SERC. We now take time to honor and felicitate the giants on whose shoulders we stand, whose leadership laid the foundation of all we celebrate today. We now take time to felicitate our former director, Dr. N. Lakshmanan. We are deeply honored to felicitate Dr. N. Lakshmanan, a stalwart in the field of structural engineering, whose illustrious career has been a beacon of knowledge, leadership, and unwavering commitment to national service. A distinguished alumnus of the University of Madras and IIT Madras, Dr. Lakshmanan joined CSIR-SERC in 1975, rising through the scientific ranks to eventually serve as its director. His expertise spans across diverse and critical domains, including structural dynamics, wind engineering, blast-resistant design, and disaster mitigation, fields in which he has made pioneering contributions that continue to shape national policies and engineering practices. We are joined with us today, Mrs. Lakshmanan, who will be receiving the felicitation from CSIR-SERC. I request the dignitaries on the dais to do the honors. We salute Dr. Lakshmanan's extraordinary journey and lifelong dedication to science, resilience, and public good. Dr. Lakshmanan remained a pillar of support to CSIR-SERC, and even during the challenging times of COVID pandemic, he was working for us. A big round of applause, everyone. Thank you, ma'am. We now move on to felicitate Professor Nagesh R. Iyer, former director, CSIR-SERC. We take immense pride in felicitating Professor NRI, a visionary leader, eminent engineer, and revered scientist whose remarkable journey with CSIR-SERC has left an indelible mark on the field of structural engineering. Beginning his career in 1977 as a senior scientific assistant, Dr. NRI rose through the ranks with steadfast dedication and intellectual rigor, culminating in his tenure as director of CSIR-SERC from 2009 to 2014. We are now joined with Mrs. NRI, and we are honored to felicitate Dr. NRI. As we honor Professor Nagesh Iyer today, we celebrate not just his achievements, but his enduring legacy that continues to inspire generations of engineers and researchers. We now move on to felicitating Professor Santosh Kapuria. It is with immense pride and deep admiration that we felicitate Professor Santosh Kapuria, an eminent scholar, visionary leader, and a trailblazer in the field of solid mechanics and smart structures. As a chair professor at IIT Delhi and a fellow of all 4 leading science and engineering academies in India, Professor Kapuria stands among the most respected and accomplished minds in the nation's scientific community. Professor Kapuria brought to CSIR-SERC a unique blend of academic brilliance and industrial acumen, honed during his tenure at EIL and later at IIT Delhi. As director of CSIR-SERC and coordinating director of CSIR Madras Complex from 2015 to 2020, he led the center into a bold new era of innovation and impact. As we honor Professor Kapuria today, we celebrate not only his leadership, but also his enduring role as a torchbearer of innovation, scientific integrity, and collective spirit. A big round of applause, everyone. His journey continues to inspire generations of researchers and engineers, both within the CSIR family and far beyond. We now move on to felicitate Shri Zakaria George. We are privileged to felicitate Shri Zakaria George, a pioneering engineer, visionary leader, and an enduring contributor to the field of concrete technology and construction engineering in India. A distinguished alumnus of the University of Kerala with further training in engineering and management, Shri George's illustrious career is a testament to his relentless pursuit of excellence and innovation. We are honored to celebrate Shri Zakaria George's legacy, a life devoted to engineering advancement, mentorship, and nation building. We now move on to felicitating Mr. Janaki Raman, who has served as a technician for CSIR-SERC. At 86 years, he has joined here today to be with us, and we are honored to felicitate him today. A big round of applause. We now move on to honoring our other retirees. I now invite our AO and FAO, Shri Loknath Patnaik AO and Shri Anis Ahmad Pasha FAO, to announce the names of retirees. For want of time, we are reading the names in random order, not in the order of seating, while our director will be personally extending the honor to each retiree in their respective seats. So I request the retirees to receive your honors in your respective seats. Our director will be coming and bestowing the honor. Big round of applause, everyone.
Good evening, one and all. Among the retirees, one Mr. Ramanathan V. is not available present here. His age is 97 years per month as on today. So I will read out the names of the retirees present here. Sri M. Murugesan, Dr. N.P. Rajamani, Sri R. Raghuraman, Sri K. Raghavan, Sri V. Chalapan, Sri R. Ravindran, Sri R. S. Ramanujam, Dr. K. Balasubramanian, Sri K. Shankar Narayanan, Dr. K. Mudumani, Sri S. Abnachalam, Dr. K. Ravi Shankar, Mr. Lalita Chanapa, Sri V. Sundaram, Sri V. Giri Prasad, Sri K. P. Rajalu, Sri V. Gopi, Mr. V. Lata, Sri K. Dilli, Dr. Maimun Mogul, Sri S. J. Murthy, Sri R. Gurmurthy, Sri N. G. Bhagavan, Sri S. Annamalai, Dr. P. Gandhi, Sri K. Nagajoti, Dr. G. S. Balani, Sri C. Babu, G. Victor, Paul Raj, Dr. P. Shivakumar, Sri C. Jayawal, Sri S. Krishna Kumar, Dr. P. Srinivasan, Dr. C. V. Vaidyanathan, Sri V. Ravi Kumar, Sri P. Muthusamy, Sri R. Manoharan, Sri V. Mutalavan, Sri R. Shekhar, Sri M. Sengudwan, Mr. Chitra M. Hariharan, Sri K. Sivaprakasham, Sri R. Ramanathan, Sri R. Venkatachalam, Sri A. Sundarmurthy, Sri P. Kanagaraju, Sri A. Challapan, Sri S. Elumalai, Dr. N. Gopalakrishnan, Sri K. Sridharan, Sri B. Subramania Iyer, Dr. Zakaria George, Sri Srimati R. Anandavalli, Sri K. Muralidharan, Dr. A. Hariharan, Srimati M. Anasalvi, Sri E. Umachandran, Srimati S. Jayalakshmi, Sri R. Venkatesan, Dr. N. Prasad Rao, Sri V. Chandran, Sri R. Nageshwara Rao, Mr. S. Suryakala, Sri E. K. Jayaraman, Sri K. Vasudevan, Srimati Rukmani Raghavan, Sri T. Tangam, Dr. V. H. Bharat Kumar, Sri T. Srinivasan, Sri M. Dulip Kumar, Mr. P. Rani, Sri G. Govinda Rajalu. Rest of thing I request if sir to
Sri S. Mariam, Sri J. Devan, Sri T. Janaki Ramaya, Srimati A. Muniyamma, Sri M. S. Munyanathan, Sri M. Sankaran, Sri R. Perumal, Sri Vijay Kumar, Sri K. Mangathan, Sri M. Venkatesan, Dr. C. K. Madeshwaran, Sri Ganesan, Sri G. Raju, Sri R. Kandiyappan, Sri N. Sridhar, Sri M. Nathan, Mrs. Komulawapati, Mr. J. A. Victor, Mr. P. Manivasagan, Dr. K. Sasikala.
We sincerely appreciate your understanding if the names announced do not match the sequence in which the honors are bestowed. For want of time, we are doing this. I request everyone to give a big round of applause for the honored retirees. They are not just retirees, they are keepers of our institutional memory. We are honored and privileged today that more than 100 retirees have joined with us today. It's a big moment for us.
Sir, camera पर मैडम కొంచెం ఉన్నాడు రెడీ కెమెరా సార్ అప్పుడు ఇంక వరకు మేడం
The retirees are presented today with a memento to commemorate their service to CSIR-SERC along with the kit. The kit will also be given to the retirees.
Thank you, sir.
Our volunteers will be distributing the kit along with the mementos. I request the serving members of CSIR-SERC to honor the retirees with a big round of applause.
Thank you, sir.
Madam, one sorry. Madam?
Thank you for being here.
இது முடிச்சிடும். ஓகே.
Sir, camera back, sir. Madam. Thank you. Thank you. Madam. Thank you. Madam.
Sir, కొంచెం.
Madam. Madam.
Sir, வாங்க.
WhatsApp.
மேடம் வாங்க. மேடம் இங்கே முடிச்சு. ஃப்ரண்ட் ரோல இங்கே இருந்து. சார் ரைட் சார் இங்கே சிட் ஆன் சார்.
जी लाइट
Thank you.
Madam, இங்க வாங்க.
கொஞ்சம் வெளியே சார் அந்த
சார் கேமரா பார்க்கலாம் சார். சார் கேமரா பாருங்க.
கொஞ்சம் அப்படியே வெளியே
இந்த சைடு சார் கேமரா
We are deeply honored and humbled that all the retirees have taken time out today to join with us in this celebration. We are incredibly privileged for your service. We stand today because of you.
Madam, sir, please silent. Sir, camera पकड़ा sir. Sir, camera पकड़ा. Sir, camera पकड़ा sir. Sir, camera पकड़ा. Thank you. Sir, camera पकड़ा sir. Thank you. Sir, camera पकड़ा. Thank you. Sir, camera पकड़ा sir. Sir, camera पकड़ा. Thank you. Back. Sir, camera
On behalf of CSIR-SERC, I once again thank all the retirees for taking your time out and joining here today.
Ready sir, camera पकड़ा sir. Sir, wait sir. Thank you. Sir, camera पकड़ा sir. Sir, camera पकड़. Sir, camera पकड़ा sir.
I request any of the retirees who have not received the memento to kindly collect the mementos. If we have missed anyone, I request to please kindly collect the mementos.
Yeah.
I request if any of the retirees did please kindly collect the mementos.
So I thank all my beloved seniors. It's really an emotional moment for me because I joined this institution as a junior research fellow, and many of you were much senior than me. And it's really, I'm honored to do this. Thank you, everyone.
As we move on to the new chapters, please know that your footprints remain etched in the corridors of CSIR-SERC. A big round of applause once again to honor our retirees. A big thank you from all of us. We now present the inauguration of ACSIR Science Club C-Struct, a new platform to nurture scientific curiosity and collaboration. C-Struct is commencing today with a mission to lead the transformation of civil engineering with the student-led AI ecosystem, fostering innovation and driving profound socio-economic impact. C-Struct's vision is to drive the beneficial integration of AI into civil engineering, aligning with the National AI Mission, develop innovative AI solutions for civil engineering challenges, and foster a collaborative AI ecosystem in civil engineering, connecting students and professionals. This video now follows to mark this launch. A big round of applause for the launch of C-Struct, please.
Stands the CSIR Structural Engineering Research Centre, Chennai, a pioneering institution shaping infrastructure for over 60 years. In partnership with the ACSIR, Academy of Scientific and Innovative Research, CSIR-SERC powers transformative research and nurtures the next generation of engineering leaders. Now, stepping boldly into the era of artificial intelligence, we proudly present C-Struct, the AXA Science Club at CSIR-SERC. C-Struct is a student-driven initiative designed to integrate AI into civil engineering, aligned with India's national AI mission. Our mission: drive meaningful AI adoption, develop innovative solutions, and build a collaborative ecosystem of students, researchers, and industry professionals. Officially launched on CSIR-SERC Foundation Day 2025, SEI-Struct was unveiled with a promotional video and brochure marking a new chapter in the future of engineering. Through our AI lecture series, we explore cutting-edge topics like we look at how digitizing historical civil data can open up new possibilities, and how artificial intelligence is being used to improve concrete quality. Plus, we explore generative AI for design, structural health monitoring, and environmental sustainability. It's all about preparing ourselves for the future, one lecture at a time. Our Society Outreach Initiative translates cutting-edge research into real-world impact, empowering communities through the CSIR 800 program by promoting the use of locally available materials for engineered construction. Civil engineering hackathons, including AI, will be conducted among third-year bachelor students in and around Chennai. And by leveraging the wisdom of our ACSIR alumni in artificial intelligence, civil engineering and industry, we mentor the next generation. Together, we are engineering a smarter, more sustainable future. Join CSIR-SERC. Let's build what's next.
A big round of applause for CSIR-SERC. Next, we move on to the prize distribution for poster presentation. As a part of Diamond Jubilee celebrations of CSIR-SERC, a poster preparation competition was held on the theme CSIR-SERC at 2040, inviting imaginative visions of our institute's future. A total of 11 thought-provoking posters were submitted, and now I call upon the winning teams. The first prize is won by myself and Dr. Mohit Verma and Dr. Kirtana. I now invite Dr. Mohit and Dr. Kirtana to collect the prizes. I request the chief guest to do the honors.
The second place goes to the team consisting of Dr. P. Prabha and Smith Lakshmi Purna.
I now invite Ms. Prabha, Dr. Prabha and Srimati Lakshmi Purna to collect the second prize for the poster. I call upon the third prize winners, Dr. Senthil Kumar and Dr. Ambali, to come to the stage to collect the prizes. Dr. Senthil Kumar and Dr. Ambali, the third prize winners. Big round of applause, everyone. Thank you so much, sir. Thank you, ma'am. Behind every successful event is a dedicated team, silent efforts, and meticulous coordination. I now invite Shri E. Mahesh Kumar, Controller of Stores and Purchase, CSIR-SERC. Before that, we would like to honor the retirees who have retired during 2020. During COVID, because of that, we are not able to felicitate them in the stage, and we now take this opportunity to felicitate the retirees of year 2020. I now call upon Shri K. Dilli, Senior Principal Scientist, to come to the stage. Big round of applause to Shri K. Dilli, Senior Principal Scientist. He has retired on 30/9/2019. Next, I call upon Shri K. Raghavan, Principal Technical Officer, who was retired on 31/10/2019. Next, I call upon R. Gurumurthy, Private Secretary, who has retired on 9/1/2020. Big round of applause for our retirees. Next, I call upon Mr. Chandran, Assistant Section Officer, who has retired on 23/1/2020. And last but not least, I call upon Shri S. Krishna Kumar, Senior Technical Officer, who has retired on 29/2/2020. I think he's just left, ma'am. We'll make sure that it reaches him. We thank one and all for your service to the organization. We now move on to the vote of thanks, the end of today's function. I now request Shri E. Mahesh Kumar to deliver the vote of thanks.
Good evening, ladies and gentlemen, respected dignitaries on the dais, erstwhile colleagues, and my present colleagues. We are now in the closing hours of such a mega event, Diamond Jubilee celebration, and the need of hour says we should thank all those who have contributed for this last 60 years. First, let me say that one of the finest features of human being is gratitude, saying thanks. Thanks to everybody who has contributed, who has been with us, who have led us on this occasion. So first let me at the outset thank and take this opportunity to thank all our leaders right from the day of Professor G.S. Ramaswamy to our present day director, Dr. N. Anandavalli, who have put SCRC in the world map. There is a lot of changes and SCRC has done all that and they are. Let me also thank our chief guest, Professor U. Mudali, and guest of honor, Dr. Ramji Singh. Both the guests are members with hectic schedule and they have carved some time for us from their busy schedule to be a part of this Diamond Jubilee celebration at SCRC. It's a great honor for us. Sir, we thank you. We thank Professor U. Mudali. We also thank our guest of honor, Dr. Ramji Singh. I also take this opportunity to thank our former director, Professor Santosh Kapuria, sir, who has always been a part of our celebration and he has been a guiding spirit for us in the last few years. Thank you, sir. For any occasion and such a mega event to be a success, we should have a strong leader. And the leader who is very committed, dedicated, troubleshooter, and in this regard, our beloved director, Dr. N. Anandavalli, has been a continuous source of inspiration, who is a very good planner and also a troubleshooter. We thank you, madam, for all the inspiration, motivation, troubleshooting, and steering us through all the time for the success of this year-long event. It also becomes my duty to thank all the participants, audience, retirees who have come for this mega event of the Diamond Jubilee celebration and allowing us to carry a big memory of this Diamond Jubilee celebration. Actually, now we should thank for the wonderful ambience. We have a very good ambience of this event, and this is possible only because of many untold services from various persons of various departments like horticulture, electrical, civil, IT, administration, accounts, purchase, and various committee members also from the canteen. This list is not exhaustive. I might have missed some, but this is not intentional. I finally thank one and all for all the success that has been in this mega event. Thank you, one and all.
Thank you very much, sir. As we draw curtains on this milestone event, I leave you with this thought. Structures may age, but institutions evolve. As long as passion, people, and purpose come together, we build not just structures, but legacies. Thank you all for being part of this historic celebration. Let us continue building structures and legacies that stand the test of time. Jai Hind. I now request all of you to raise for national anthem. Thank you all. I request the retirees to join for a group photo inside the auditorium. Please be seated in the middle row so that we can take the photo from the stage. I request the retirees to please be seated in the middle row of the auditorium so we can take a group photo.